Whenever possible, it's most desirable to use the actual scores when you're calculating measures of variability. However, sometimes all the data we have access to is in the form of a grouped frequency distribution. On this Excel sheet is an example of such a distribution. You can see on this table that 7 people scored between a 50 and a 58 on some measure, but it's just unclear what those scores were. Were the scores all 58s? Or was there one 58, a couple 57s, and the rest were 53s? Unless we have the raw data that made up this group frequency distribution, we will never know. But all is not lost if all we have is a group frequency distribution, because we can approximate the mean, variance, and standard deviation using the midpoints as proxies for the scores in each interval. The first thing we'll want to do is look at two formulas that will help us with our group frequency distribution. The formula here at the bottom demonstrates how to find standard deviation in a grouped frequency distribution. So according to the formula, we're going to sum up the frequencies times the midpoint, the squared midpoints. We're going to divide that by the total n and subtract the mean squared. Okay, and then the upper formula just tells us how we're going to find the mean in a grouped frequency distribution. So for this formula, we have f and we have n, but we need the midpoints and the midpoints squared and the frequencies times the midpoints for the mean. So let's construct all of these columns now. First, the formula for midpoint is the lower score plus the upper score divided by 2. Let's plug in that formula for the first score. And I'm going to put 50 and 58 in parentheses because I want that to be done separate from the division. And so I can see very easily that my midpoint is going to be 54. And that's midway between 50 and 58. Now, instead of doing the calculation for each of these, I know that the class intervals are the same size, and so I'm going to add 4 to each of these to make the midpoint. Recall from our last video that, according to the order of operations, exponents come before multiplication. And so we're going to need to square the midpoints before multiplying them by the frequencies. So in the next column, I'm going to square the midpoints. Equals, I'll get the midpoint, and I'll do the caret, and 2. And I will drag that down to have the rest of the midpoints squared. Now, when we're going to find the mean, we need to multiply the frequencies by the midpoints, so I'm going to do that in this column. All right, I'll drag those down. And I know I'm going to have to sum that up for our formula. Something happened. And there we go. So now we have the numerator for our mean. So let's figure our mean right now. We know that the mean is the sum of the frequencies times the midpoints, the FM, over the n. So our mean is going to be 37.79. And I know in this other formula I'm going to need to square the mean, so I'm going to do that right now. Equals the mean with a caret and a 2. Oh, way too many decimals. Okay, bring that back over. All right. And the last thing we need to do for this part of the equation is to multiply the frequencies by the midpoint squares. So we're going to multiply the frequency by the midpoint squared to get this frequency times midpoint square product. So I'm going to do equals the frequency times midpoint squared. All right. Then I'm going to drag the rest of that down. I know I'm going to have to sum that up. And I end up with this very large number. Okay, so now we're ready to plug in all of the terms into this formula to find, we're going to find the variance first, which means we're not going to do the square root. We're just going to do the formula under the square root. So I'm going to sum my frequencies times midpoint squared, which I already did here. I'm going to put that over the n, which is 90. And then I'm going to subtract the mean squared. And we end up with a variance of 91.19. And as we've discussed before, it's so simple to make the standard deviation. We're going to just simply take the square root of the variance. I have the SQRT right there. I'm going to select the variance. And now our standard deviation is 9.55. This example will help you with practice assignment items 5 and 6. So go ahead and complete those items in a very similar way to how we just did this example, and you should be all set. But if you do have questions with any of the practice items, please bring them to the discussion board.